Welcome to the perspective unit on code generation, in which we are going to answer some frequently asked questions as usual. So, let's see. You mentioned several times in the course that Jack is a relatively simple language. What would it take to generate code for a more realistically complex language? Indeed, Jack is very simple. To begin with, it doesn't really have a type system. All the data values are 16-bit, and the data value of any type can be assigned to a variable of any other type. This freedom allows Jack compilers to almost completely sidestep all the headache that is associated with handling typing issues. For example, when compiling and evaluating expressions, Jack compilers don't have to bother about determining the type of the expression according to the types of the constituent elements of these expressions. Likewise, array entries are also untyped in Jack. Now, in contrast, most programming languages feature rich and versatile typing systems. So, different amounts of memory must be allocated for different types of variables, 16 bits, 32 bits, 64 bits, and so on. The conversion from one type into another requires specific casting and language operations. The compilation of expressions like x plus y depends strongly on the types of x and y, and so on and so forth. All these requirements make compilation much more challenging. Another significant simplification is that Jack does not support inheritance. This implies that all method calls can be handled by the compiler statically during compile time. In languages that do have inheritance, like Java, compilers must treat method calls during runtime, because they have to determine to which class the method belongs according to the object on which the method was called to operate. This object is somewhere along the inheritance hierarchy, and this determines which methods we have to invoke. This is sometimes called late binding. And also, and this is completely unrelated to what we discussed before, Jack has no public fields. The only way to access a field from outside the class is through accessor methods that the programmer must write. So, if you look at all these things, the lack of a typing system, the lack of inheritance, the lack of public fields, all these simplifications make code generation far simpler in Jack compared to compilers of industrial strength languages. With that, let's move on to the next question. Well, this question is actually related to the first one. How difficult will it be to close the gaps between Jack and languages like Java or Python? Well, some extensions, like handling inheritance, as I just discussed, well, these extensions require significant code generation efforts. Supporting inheritance, polymorphism, late binding, that's a lot of compilation work. And yet, other simplifications of the Jack language can be easily relaxed. Well, I shouldn't say easily, but they can be relaxed with relatively little effort. And that's because they are quite straightforward. For example, we can easily add control structures like for and switch. That's not such a big deal in terms of extending our compiler. And adding more data types aside of the 3 types we have now requires more effort, but once again, the extension is relatively straightforward. Another limitation of Jack is that you cannot assign character constants to variables of type char, C-H-A-R. And in order to bypass this limitation, the Jack programmer must use all sorts of string functions, which is kind of tedious. Well, once again, that's an example of a feature that can be easily fixed in the Jack language using some, we have to both extend the grammar as well as the compiler. And indeed, I would like to observe that each of the language extensions that we discuss in general, well, each of these activities, extending the language, requires two very separate activities. First of all, the language designer has to sensibly extend the language grammar and syntax, and this is something that must be done with great care. And then, once the specifications have been extended, the compiler writer must extend the parser and the code generator in order to accommodate these changes in the language. So altogether, these are big-time changes that must be done with great care as the language evolves from one version to the other, as programming languages normally do. Now, once again, there are many things that can be implemented and improved in Jack. Most of these extensions, that's the good news, is that most of these extensions are independent of each other. And in that respect, they can be implemented by making relatively local and simple extensions to the parser and code generator that were already developed. So with that, let's move on to the next question, which is, what is the meaning of compiler optimization? Well, it's not terribly important that the compiler itself will be efficient and optimized. What's important is that the compiler will generate low-level code which is efficient and optimized. And I hope you understand this distinction. For example, consider a high-level statement like x++ in, say, Java. A naive Java compiler may translate this statement into push x, push 1, add, and pop x, x++. And then the VM translator will kick in and translate each one of these 4 VM commands into several machine level instructions. We'll end up with something like 50 lines of code. And so the result will be, a considerable chunk of code. At the same time, an optimized compiler may notice that what we have here is simply a variable incrementing operation. And with that in mind, the compiler, or the optimized compiler, will translate x++ into 2 machine instructions only, at x followed by m equals m+1. That's at least what we could have done in the Jack Hack platform. Of course, this is just one example of many optimization tricks that are expected from a full-service compiler. In general, the ability to generate compact code that uses as few cycles and as little hardware resources as possible, well, this ability is a very attractive feature of code generation and compilers in general. Well, none of this optimization was done in the VM translator that we developed in this module. So to wrap up my answer to this question, I would like to comment that even though the code generator that we developed is unoptimized, it still represents a sophisticated and substantial piece of engineering. So once you complete developing this code generator, you should feel very proud of your accomplishment. You've just finished developing a compiler for an object-based Java-like language. So, mazel tov. And with that, that's the end of our module 5. And in the next module, we're going to develop an operating system. And this operating system will be developed using the Jack language.